So it's higher level paper 1, question 5. This question is rather trivial with a graphic calculator, but we'll go for it anyway. We're wanting to draw the graph of this function, so I'll press the template button to get the absolute value template, and I'll type in cos, or instead of using a keyboard, I'll press trig twice to pull up the cos command, and then I'll type x divided by 4. And then I press enter. Now I need to make sure that I'm in radian mode for graphing, so if I press menu, choose settings, and change my graphing angle to be radians and make that a default, and click OK, I think a graph that might look familiar compared to anything I may have sketched on the page. And what I need to do is change the axes so that it looks at the window I'm interested in. So we're interested going from 0 to 8 pi, 8 lots of pi, like so, and we'll go up in steps of just 1 pi. That would seem appropriate. I'm going to change the y-min. Well, it's never going to be negative because of the absolute value function, so I'll just change that to be just -1, and maybe we want to set this to just be +2, and we'll go up in steps of 1. Let's see how that looks like. There we go. It's looking very nice indeed. Now we're looking to find out when this whole thing is equal to 1/2, so by just typing in another horizontal function of 1/2, we can see that there are going to be 4 solutions there. We can go along and pluck out each of them, and if I just go ahead and do that, so analyze graph, we'll do the intersection of the first one, menu, analyze graph, intersection of the second one, and so on and so forth. Now we can sometimes speed this up if you have access to geometry, menu, geometry, points and lines and intersection points. It will find all of them. If I click one and then click the other, it finds all 4 solutions all at once. Press to test mode may prevent you from doing that, but we have our 4 solutions. Obviously the first couple were generated twice there. We have our value there, and we have our value there. So those are 4 solutions. Now we're going to see if we can come up with exact values of multiples of pi for this to check any workings we may have done on the page. So I'm going to store each of these. I'm going to store that as, I'll call it x1 for the first solution. Go over the number, press, go over the number 8.38. Let's get 8.3 faded. Press Control menu to store it, and we'll call it x2. Go over 16.8, Control menu to store it. I'll call it x3, and go over Control menu, store it, and I'll call it x4. So there's my solutions. Now what I'm going to quickly do is go to a calculator page and set up a list of my solutions, my sols, and I'm going to define that being equal to, and I'll do curly brackets, so that's control right bracket, and I'll call it x1, comma x2, comma x3, comma x4. And when I press enter, I'll get all of the decimals. And the reason I do that is I want to divide them all by pi and see if they come out to be nice fractions of rational numbers. So with all these numbers, if I divide them all by pi, I get numbers which do look familiar. With that answer, I'm going to do menu, number, approximate to fraction. I may just reduce the accuracy of this because they all look as if they're something to do with thirds, and there are my fractions. I've got 4 pi by 3, 8 pi by 3, 16 pi by 3, and 20 pi by 3. And we're done.